You are welcome to ask questions throughout the presentation. I'm going to go ahead and show the chat here in Teams so that I'll be able to see that. But I might defer questions to an appropriate part of the presentation. But you are welcome to post questions, and we can have some live Q&A as we go. So this is what we're going to talk about. We're going to talk about different model schemas, and then we're going to move pretty quickly into dimensional modeling, and then we'll talk about some of the tenets of dimensional modeling and what dimensional modeling is all about. What's old and what's new? A lot of it's old, a lot of it's the same, and that is really kind of an important point that I'll be reinforcing. And then we'll break that down and talk about role-playing dimensions. We'll talk about bidirectional filters and relationships, how to model many-to-many relationships, and then we'll talk about some techniques specifically in Power BI using disconnected tables and then layering DAX over the top of your dimensional model with both relationships and disconnected tables, and we'll talk about some techniques that are fairly common in a correctly modeled Power BI solution. And I'll mention some external tools, then we'll talk about composite models a little bit, but I'm going to spend some time doing some demonstrations and talking about and demonstrating these concepts. So there are different ways that you can model data for reporting, and categorically, I see the world in this way. I see that there are flat models, that there are master detail models, and models that are layered after multiple instances of master detail relationships, and then dimensional models. Now, that's not to say that this encompasses, every incarnation of the way that you can model data together and the way that we can shape data, but I think categorically this kind of covers the bases. So let's break that down just a little bit. So the world is not flat. Some of it is. Some data is flat. If you are a person who works in the finance space and your tool of choice is Microsoft Excel, you're probably accustomed to seeing the world in a flattened view, of taking any data that you might consume and putting that into a spreadsheet with rows and columns. And that's a good thing. That might meet a certain need, and it might be an appropriate way to shape data. So let's look at a flat table. Now, this is a very simplified example for the purpose of demonstration, but if we were to look at some retail sales data in a fairly common spreadsheet view or worksheet view here in this table, we can see that over here on the left side I have 3 date columns. So they represent 3 different events that have occurred relative to a customer sale: order date, due date, delivery date. Here's some customer information. Now, again, for the purpose of simplicity, I just have a company name, and then there's a key that we could use to go look up a customer in another system. Here I have product information, and products can be organized into categories and subcategories, and of course the product name, and we could have other things like the stock keeping number and different attributes of products. And then over here on the right, I have 3 columns that are numeric. And what do we typically do with numeric columns? We usually add them up. We aggregate them in some way. We could sum them or count them or get the min or the max or the average or the standard deviation. There are lots of different things that we can do with numbers. Okay, so far this is pretty straightforward. This is what people are accustomed to doing with data, even people who aren't necessarily data professionals. But because the world is not always flat, and as we need to scale, and as we need more utility from our data, the dimensional model was born. So this idea of the star schema is not new. It's been around for a long time. The tenets of the dimensional model are that we have a fact surrounded by dimensions. It's related to dimensions. Now, a single model could have multiple facts. So you could have a store sales fact, and you could have an online sales fact. We could have an inventory fact. So we could have a targets or a goals fact. And what is a fact? Well, a fact is just a statement of something that I measure, a fact in my business. We sold something, certain quantity, certain price. You know, they're those numeric things that we add up and perhaps form some calculations around. Dimensions are the way that we describe facts. And so in a properly modeled dimensional model, things like customers and products and dates are stored in separate dimension tables. So this is a materialized version of the star schema. The star doesn't necessarily mean that there are 5 dimensions all the time. It just means that they're related with the fact in the middle. So in this case, I have a customer dimension, a product dimension, an order date, and a store dimension. All right, so what is a dimensional model? It's a general best practice. I use the term general very deliberately because it's not a cure-all for all data, and it doesn't necessarily meet every single need that you might have for reporting or managing your data, but it's a general best practice. A dimensional model will generally improve the performance of reports and queries. It will generally help you get more accurate results, but it's not an absolute for managing simple attributes. What do we mean by that? Power BI, like other self-service modeling tools or self-service reporting tools, really allows you to break these rules. Okay, it doesn't force you like previous products from Microsoft and other vendors like Cognos and you know, business objects and SQL Server analysis services in the Microsoft space really kind of forced you to pound data into a multidimensional shape before it would be useful. Well, Power BI, because it's trying to keep up with the times and kind of be all things to all people, both data professionals and for you know, people who work with less sophisticated data sets, doesn't force you to dimensionalize your data. And so it might make sense to have a table that has a few different dimensional attributes right there in, let's call it the fact table. But as you kind of grow up and as we need to scale, that becomes more and more important. So there are rare exceptions where we may not necessarily use a dimensional model to meet all of our needs. So where did these dimensional modeling rules come from? Well, this group are generally credited with the invention of the dimensional modeling rules. This is Ralph Kimball in the front row there, who led the Kimball Group. Now, the Kimball Group was in business for almost 30 years. They were a consulting shop there in the Bay Area, and they wrote the Bible on dimensional modeling, the Data Warehouse Toolkit and other related books. Ralph traveled and did presentations and symposiums and training classes. A lot of his consultants did the same thing. And like I said, they wrote the book. Their website, kimballgroup.com, is one of the best places to go to learn about the details of the Kimball method and the dimensional modeling rules. So what are they? It's a simple method. Select a business process. Once you've isolated a specific business process, then you're going to declare the grain across different dimensions. What does that mean? Well, it means that we figure out how low we need to go. Not how low we can go, but how low we need to go. So across a date hierarchy, for example, maybe our recording requirements only require us to get down to the month. We don't need to go down to the day. Maybe we don't need to go down to the customer's address. We just need to know what city or what state or province a customer is in. So we need to ask these questions about every one of those dimensions. Obviously, we identify the dimensions, and then we identify the facts to go along with those dimensions. Now, there's a whole set of steps that are prescribed in the Data Warehouse Toolkit. I'm actually packing up my office. We're getting ready to move and downsize a bit, so I've taken away all of my books. But you know, a month ago, I would have reached behind me and I would have pulled out a copy of the Data Warehouse Toolkit and shown you that it's about 3 inches thick. It's a heavy book that essentially breaks all of these steps down. Now, since the Kimball Group has folded up shop, some other folks have stepped in and have kind of modernized the Kimball approach. That's not to say that any of these concepts need to be retired. They're as true as they've ever been. However, one of the people who I've done a lot of reading with and have used his techniques is a gentleman by the name of Lawrence Cord. He wrote a book called the Agile Data Warehouse Design. Agile Data Warehouse Design. He promotes an approach called model storming. It really begins with asking questions like who, what, when, where, why, and how. Once you've answered those questions about a particular business event, something that occurs in business, customer buys product, consultant bills customer for time, then we break that down and we create a matrix, and we can distill the answers to those questions, the 7 W words, and we can transform that into a matrix that eventually describes dimensions on columns and the attributes of those dimensions, and then the facts and measures in logical groups across rows. And so in the technical world, we see a schema that could look like this. We transform source data into a dimensional star or a snowflake. All right, so there's the process. But let's break that down and talk about how we actually implement a star schema. So one of the important concepts that are very important to understand, and a very important decision that you will need to make as you're modeling your data, is to understand how role-playing dimensions work. And a role-playing dimension really simply means that I have an entity, a dimension, that might serve multiple roles. And the most common example are dates. We can have an order date, a due date, a delivery date, and we may or may not need to materialize different versions, different copies of that core table, that date table in this example. Well, I wanted to give a different example, so I'll use this one. So everybody's been on an airplane, less so in the last year or so, but if you think about a flight, a flight is a ride on an airplane that begins somewhere and goes somewhere else. So there is a departure airport and there's an arrival airport. So if I fly from San Francisco International Airport to Portland International Airport, the airport is a common entity. Okay, an airport is a place where airplanes can fly out of and fly into. But for the purpose of describing departures, I'm only interested in talking about the airport in that role of a departure airport. That's where airplanes fly out of. And then I have another list of airports that we fly into. So since we have a departure airport code and we have an arrival airport code, in this case, I might materialize that table 2 different times, so it can serve both of those roles. So here's an example of my sales table, fact table, and my date table. You can see that in Power BI, I can only have one relationship between tables. Therefore, I might materialize that table multiple times. That's not to say that we always do, but I might need to do that. Now, this opens up a really big question. Let's say that I have a table that has a whole bunch of dates, and we might look at that and say, okay, well, I've created my date dimension table. That might exist in my data warehouse, or I might use Power Query to actually create a table full of dates with 1 row per date. Just because I have 9 different columns in my product order table that are date types, does that mean that I need to materialize the date table 9 times? And I would say no, that's not a good justification for doing that. The question is, do you need to be able to prompt a user in a report 9 different ways and perhaps let them traverse date hierarchies? Do I want to say, all right, I want to see all product orders where the confirmation year is a certain year, where the inquiry date month is a certain month, where the order date is a certain month or quarter. So in order to take advantage of those hierarchies and be able to have the flexibility of being able to do date math and logic, it might make sense to materialize certain date tables, but not all of them, not because they're there. We want to do that because we have a stated reporting requirement, a business requirement that says, I need to be able to let a user select a year and then a quarter and then a month that's related to confirmation date, et cetera. All right, so I got ahead of myself here. Should every fact key value have a corresponding dimension table relationship? And the answer is, it depends. Thank you very much. I'm a consultant. I bill for that answer. All right, bidirectional filters. So in Power BI and SSAS tabular models, when you model a relationship between two different tables, naturally those relationships are generally one to many, not always, but one from the dimension side, many to the fact side, and generally speaking, by default, the directionality of the filter through that relationship flows from the one side to the many side. All right, well, why would I want an exception to that rule? So let's say that my business requirement for a report is that we want to provide a list of customers. Customers have sales, sales have products. When I select a customer or a combination of customers, I want to see a filtered set of the products that those customers have purchased through the sales table. Sorry, I must have hit the back button or something there. So naturally, that's not going to happen. Now notice that I have created a bidirectional filter here, but if I had left that as a single direction filter from the one side to the many side of this product to sales relationship, the filter would propagate from the customer, where I've selected a customer in my visual, I would get a filtered set of sales, but I would not naturally see filter propagation from sales to product, which means that the sales table visual or chart or whatever I've used is not going to get filtered when I select a customer. If I change that to a bidirectional filter, it would. And so you might think, well, heck, why don't I just change all of my relationships to bidirectional filters? I will quote Alberto Ferrari in a talk he gave at the PASS Summit about 5 years ago. He said, if you use a bidirectional filter, you will go to hell. And I'm having fun with that, and so was he when he said it, but it really made the point in my mind that this is a bad thing, that this could be a bad thing because it's going to affect performance. So you need to have a good reason to use bidirectional filters. And one of those reasons is to implement many-to-many relationships. I do not use the many-to-many relationship capability that's built into Power BI. If you drag and drop between two tables, you drag and drop a key from one to the other, where the data suggests there's a many-to-many relationship, the modeling engine will infer a many-to-many relationship, but you can get very strange and difficult to explain results. So this is the way that I would model a many-to-many relationship, and most professionals would agree. If we want to select a customer, customers have accounts. An account can belong to multiple customers. A customer can have multiple accounts. Therefore, we must have a bridge table. You can see that here I have the natural single direction relationship from customer to account customer, as we do from account to account customer. If I select a customer, it is not going to filter the account for the same reason that I mentioned before, because that's a single direction filter in the wrong direction. If I were to somehow filter accounts, we would get a filtered set of transactions because of the directionality of this filter. Therefore, oops, sorry, I thought I had an animation in this slide, and apparently I didn't do that. If we were to change the directionality of this relationship, that would meet my requirement. It would let me select a customer and see their transactions at a cost. There would be a performance cost if we do that. Okay. disconnected tables. So we don't always have to create relationships. In fact, sometimes it makes sense to create a table and just put it out there in the model so that I can use it to implement some dynamic reporting capability, typically to drive a slicer or a filter, typically a slicer, and then write some DAX that takes advantage of that selection. So I'm going to show you some examples. So I won't break this down. I will show you this code before I demonstrate it. So here's an example of where I have a disconnected table called selected measure period. And that's simply a list of these values. So these are just variations of a measure that, that implements some time intelligence. So if my user were to select the value current from a slicer, they're going to see the store sales quantity. If they select MTD, meaning month to date, then I want to swap out that measure and I want to show that user the month to date values. Same thing for year to date, same period last year and prior year. So this is a very simple DAX measure that actually does that. And let's demonstrate. All right, so I know that I've got a few Power BI files open, so let me just make sure that I've got the right one here. Pull it down to my presentation desktop. All right, so we're going to take a look at actually, that is where I wanted to be. Let me take a look at this one really quickly. Yep. All right, so just to keep this nice and simple, the first thing I'm going to do is I'm going to remove my fancy measure, and I'll just put the plain old online sales quantity on values in this matrix. All right, let's get rid of our totals as well. So let's go to subtotals. We'll get rid of the row and column subtotals. What have I done? Why in the world am I saying fiscal month to date? Because I put the current period value on there. Just a second. Let's turn that into a table just to simplify things a bit. And there we go. We'll get rid of period as well. Okay, so as you can see, we're just looking at the online sales quantity. So if I wanted to see, and I do have 3 columns from my date table here, just so we can see the hierarchy of year, month, and date. So if I want to see month to date total, I have a version of my online sales quantity MTD here. So let's just take a look at this DAX. And let me make sure that I know that I've rebooted since I opened Zoom it last time. So let's just make sure that that's running.
Yeah, and Paul, while you're doing that, Rajesh has a question. Do we have to index the fact tables?
Absolutely not. Now, when you say do we have to index them, I'm assuming that you're talking about in the underlying relational database, so within SQL Server? Okay, so once you've imported data into the Power BI tabular model, the mechanics of that source database or wherever that data came from have no bearing on the behavior within Power BI, because I have a cached copy of that data. We could have imported data from a CSV file or from Excel or from a JSON file. Doesn't matter. The behavior is going to be exactly the same in Power BI. And so if you're using direct query, then of course that would have a bearing. We'll talk about direct query a little bit later. Right now I'm talking about import mode only, but I will address that. So if you're using direct query, you know what? Let's put a pin on that question. It's an excellent question, but right now we're just thinking about the internals of the tabular model itself. So I just wanted to show here that I have a month-to-date version of my online sales table, and that's simply using the total MTD DAX function, and then I'm using similar time intelligence functions on for my year to date, my prior year, and my same period last year, etc. But what I want to do is I want to allow my user to select whatever period they want. Now, this selected period, the table that drives this this slicer right here, is really just floating out in space. It's not related to anything at all. It's right here. And that just has a list of those values that I showed you. No relationships. That was the point. All right. So I'm going to turn this back into a matrix, and we'll put the month name back up there where it belongs. Let's just leave the online sales quantity in there for now, so you can see that it's doing what it's supposed to do. As I go all the way down to the month to the date in the right order, then that's doing the right thing. But what I would like to do is I'd like to be able to select a value and see the appropriately added value. So I'm going to remove this measure, and we're going to put my online sales quantity selected period on values. Now you can see that it doesn't show me anything at all because the script in here is saying I'm only going to perform any of these calculations when there is a selected value, when that period actually has a value. So if I select current, then I'm going to get the current value. If I select month to date, then I'm going to get that accumulating month to date. Let's go to the next month so you can see the values starting over again. And, you know, and so on. There's the prior year, there's the same period last year, here's my year to date, etc. All right, so, I'm playing a little bit of a shell game inside this DAX to be able to get that result. Well, I can also do something kind of fancy by going and getting this period field. So we'll go to the selected measure period, and we can place that on the columns axis and group by period. So you can see I've selected current. I'm seeing current in the column header. If I select month to date, I'm going to see MTD in the column header, and I'm going to see my month to date accumulated values. If I hold down Control and I select multiple things, I get one column per. So it's a very dynamic experience. Wasn't a heck of a lot of work to get there. All right, so my next demonstration . We're not going to do the dynamic rank X, but I'm going to show you another way that I can use a disconnected date table to show orders pending delivery. Now, this is a technique that actually I started using when I was working with a customer in the insurance business. They needed to see a count of claims that were open after a certain period of time. And the definition of an open claim is a claim that has been open but hasn't been closed, or hasn't been closed as of a certain date. So we could apply the same thing to retail sales and think about Amazon. You place an order, and so in a table we now have an order date, and it has a value. And that order is going to be out for delivery at a certain time, and then eventually it's going to get delivered. When it's delivered, then the delivery date will have a value. So if we take a look at go find my page first of all. Orders pending delivery. reminding myself quickly what this measure is called. It's called online orders pending delivery. Okay, and there I'm going to actually just count my records in my online sales table. So each row represents a sale. So what I want to do is I want to be able to see either for a selected date or with dates on the x-axis of a column chart like this for each day. I want to collapse that so I don't reveal the answer here. For each day, I want to see how many orders meet this criteria of the sale has occurred, so there is an order date that is before or on this date, in this case 7/24 of 2009, but the order has not yet been fulfilled. It has not yet been delivered. So the delivery date could be in the future, or it may just not have a delivery date at all. Well, how do I do that? Well, in order to place dates on the x-axis, I'm going to use a disconnected table. So in this case, I have a table called select effective date. And once again, you'll see that that is just a disconnected table. It's just an instance of my date dimension table. If we were to go to Power Query, you would see, and because I'm not connected to my my data source or my files, you'll see some errors in here. But you'll see that I have just a regular date dimension here, but to be able to create this select effective date, what I've done is I just right-clicked here and I said reference that. And then I called it select effective date, and then I just removed all of the columns that I didn't need. I only needed dates, so I just whittled that down to one column. So each of these disconnected date tables were created that way. And then I placed that onto the x-axis, and then I created this DAX measure. And what I'm saying here is I have to have an effective date. Now I could use selected value here. I chose just to use min, but I'm going to get one date back. And so for that date, as this calculation is executed for each of the columns in that column chart, one at a time, where one date is in scope for each execution, I'm going to calculate the, I can do this right, the count of rows for the online sales table, and then I'm going to use the all function to say, throw all my filters out, start all over again. So now I'm dealing with every record in the online sales table, and then explicitly filter that with the criteria that the order date is less than or equal to the date that I've selected, and the delivery date is greater than the selected effective date. Now I could add the additional logic that if the delivery date is blank, so I just use is blank, that would also meet that criteria as well. All right, who needs relationships anyway? So how do we work without relationships, and when does it make sense to work outside of a relationship? If you can meet 99% of your reporting needs, maybe less, 95% of your reporting needs by building a star schema with relationships, everything is easy. You don't have to write a lot of DAX. You don't have to work real hard to create a complicated model, but sometimes you need the freedom to work outside of these natural relationships. And I'll show you an example of where that might make sense. So I'm looking at the time, and I know that we need to move quickly. So I'm going to show you an example. My video just hiccuped. I want to make sure that screen sharing is still working. And I am going to go back to my model. I just want to make sure that screen sharing is still working. My screen went black and came back. Mark, can you give me a thumbs up or just an indication that you're still
we can see your screen. I see your data model here.
Awesome. Thank you very much. Okay. So what I need to do is I want to be able to select a geography, maybe a country, and I want to be able to get the quantity from store sales, and I want that to be through the store. The problem that I have here is that both customers and stores, try to zoom in again, maybe not. Customers and stores are both related to geography. And so because I need that relationship to be able to get the store sales quantity from geography, I'm thinking, oh, well, I'll just enable this inactive relationship. So check that box, you're going to get this message right here. And it says you can't do that because you already have a relationship from geography to store sales. That's through the customer table. And so that's just not going to work. I just can't use that relationship. So what I'm going to do is create a measure that explicitly calculates the store sales quantity applied to the store table. So if we go to my store sales quantity, let's get to store sales. And back to store sales quantity. You can see how I've done that. Okay. So once again, I'm using calculate to say, all right, I'm going to do something special. I want to be able to filter my data before I perform this sum. But I'm going to use the treat as function to say, go get a table full of whatever geography keys from the geography table are in scope. So if I've selected a country, I'm going to have the geography key for that selected country. And take that table full of values and treat that as if I had selected the same geography key from the store table. So essentially what I'm doing is I'm explicitly applying a filter that I've gleaned from one table, and I'm applying it to another table as if there were a relationship there. And so treat as is one way to do that. There are other techniques that you can use. If there's an inactive relationship, you could use relationship. You could use a cross join. You know, there are fancier, more complicated ways to do this, but treat as is a very elegant way to do that. And then you can simply see that if I were to select North America, that is in fact changing these numbers. And you can see that it actually takes a few seconds to calculate, and that's because I think this is slow because I have 3 models in memory right now, and it's just using up a lot of memory. But that calculation will be performed. So treat as is this magical function that I actually use in a lot of different places. All right. So let's talk about direct query now. When Power BI was released, and a lot of folks, particularly relational database professionals, learned about direct query, kind of the natural instinct was, oh my gosh, Power BI lets me use SQL Server. It lets me do my thing in SQL Server. I don't have to cache or copy data. You know, I can just connect directly to SQL Server, and I will always see the data that's in my SQL Server, or Oracle, or Teradata, or whatever platform that supports direct query. And that's all well and good, but the problem is that we lose a lot of performance and we lose a lot of functionality. And so in my experience, I learned to say, you know, let's not use direct query if we can use import mode. This is an exception to the norm. Direct query has purpose, but there are so many trade-offs when using it that it should not be your first your first selection. So to the earlier question, if I'm using direct query, is it important that I index my tables? Yeah, just as it's important to index tables in any case. Should you index fact tables? Well, if there are very common reporting scenarios, most users are going to sort by or group by date first and then by product, then it might make sense to index those keys. I'm going to say it depends. We create a lot of fact tables that we don't index simply because the indexing is, it's hard to predict what indexes are going to be used. All right, so just put that question aside. Let's talk about composite models now. So a really good use case for a composite model, and to meet our time deadline here, I'm just going to demonstrate this. Well, the first thing I'm going to do is take this model out of memory because we can see that it was not performing really well. And that's just because I've got several instances of Power BI Desktop open. Yeah, my video driver is complaining. And I think it's just because I'm doing a lot with memory. So in this copy of this model, I actually have two instances, two copies. Copy's not a very good word there. Let's go back to instance of my what table? Let's go back to the model. Of my customer table. So I had to remind myself how I'd created this model. All right, so let's look at requirements. So for the 99%, I want to give users the ability to group by, slice and filter by a handful of customer columns. That being, birth date, company name, customer type, etc. So for my model to be efficient, for it to perform well, I don't want to import the entire customer table into memory to use up a lot of space. I don't need to slice and filter by education, by gender, by the phone suffix, etc. But once we have selected a customer or a small group of customers, I want to be able to see the most up-to-date information for those customers. So what I've done is I've imported a copy of the customer table with a limited set of columns to support my analytic reporting needs. And then I've used direct query to connect to a live copy of the customer table, and you can see all of the columns there. As you can see, there's a one-to-one relationship, and I have a bidirectional filter on it. So what does this give me? Well, let's say that I'm a customer service agent and I'm looking at this report, and it's very insightful for me to be able to drill down from continent to country to city and see these metrics. All right, so I can see how many customers I have, I see my online sales quantity, etc. That's all good stuff. Here's a list of the customers. So if I were to choose, well, let's say Hamburg, Germany here. So I see a list of my customers that are in Hamburg, and I'm talking to Juan. I want to see the most up-to-date, detailed information about Juan. So I'm going to right-click. I'm going to go to a drill-through page, and this page is based on that direct query version of the customer table. All right. So I don't need to refresh my data set. I don't need to, do anything fancy at all to be able to see a record that was just updated 30 seconds ago because I'm using direct query. So best of both worlds. We have to acknowledge that there's a trade-off when importing, and there's a trade-off when using direct query. And now I'm getting the best of both worlds by doing this. All right. This is probably one of the most common use cases for direct query. Another is where we just have massive tables. You know, you've got tens of billions of rows of data, and you just can't get that into memory. Direct query then it becomes kind of a trade-off. Okay, so there's an example of where I could import a copy of store sales with a limited set of columns, and then I could use direct query over store sales. You can also create aggregations over a direct query table, which means that it actually caches pre-calculated values with different combinations of dimensional attributes. And that really gets into the advanced modeling. So use import mode 98% of the time. Use it for your mainstream requirements. And then you can use direct query typically with composite models to meet that 2% need in this example. All right, it's for the edge cases. And there's good documentation on this. So let's talk about the future of composite models. We're just about at time here, and we're just in the right place. So when I had originally put this presentation together, the future of composite models meant this feature has not yet been released. Now, there are two different flavors of composite models. About 3 years ago, we got composite models that allowed us to import tables using import mode, which means that those tables were in memory, and then we could go add direct query connections to other tables. What you could not do, and in the production version of Power BI you cannot do today, is you cannot create direct query connections to a published Power BI data set or an Azure Analysis Services database. You could import that data, but you can't direct query to it. It was announced in December, implemented in January of this year. We now have Gen 2 composite models, which allow us to do exactly what I just described. And essentially what that means is I can have a store sales data model over here, published, vetted, certified, in general use, life is good. We don't want to touch that. It's golden, it's been tested and signed off on. Over here we have online sales, another data model. That one's published, vetted, certified, all good. And now someone comes along and says, I need to combine store sales with online sales. I know that I have two published data sets. Maybe one of them is in Azure Analysis Services, and the other one is a published Power BI data set. You can now create a third model, and you can use direct query to model up and create relationships between tables exposed through those underlying models. So this is good news. They're very, very powerful capabilities. This is in public preview. You can play with it now. It's probably not going to be generally available for several months, simply because it's a big feature. It needs to be tested heavily before Microsoft is going to officially support it. This will allow you to do much sillier things than you've ever been able to do before. So use this power with caution and just realize that it requires some planning. All right, well, with that, I'll pimp my blog just a little bit here. Out at SQLServerBI.blog, I have been working on a series of blog posts titled Doing Power BI the Right Way. I would like to say that I started about a year ago, and I'd like to say that I'm completely done, but I've got a couple of these topics I have yet to complete. But you'll see that out there, and this is where I kind of brain dump my ideas about best practices. So I would encourage you to read that, comment, and ask questions. You're welcome to connect with me if you have additional questions and would like to follow up. And I will actually be starting another blog. My wife and I are actually putting our house on wheels, and next fall we're going to go on the road. I'm going to travel and continue to work full-time from our mobile office, and I will be introducing a video blog about work-life balance and being a full-time data professional on the road. And I'll promote that on the blog when it's ready. It'll be dataontheroad.blog, but there's not much out there to talk about right now. So with that, I'll go ahead and, oh, that's right, I did put my my address out there. So SQL Server BI blog is where you can go now. And then later on, you'll see the new video blog, dataontheroad.blog. So with that, I'll ask if there are additional questions. I haven't been watching the chat closely. So I see a question from Carlos. When it comes to modeling and reporting, if you have an EDW that stores several subject areas, do you recommend a large enterprise Power BI model? Or so this is the $64,000 question. Do I create one big massive enterprise model and try to, just put the whole kitchen sink in there, or do we want smaller subject area models? Okay, so Mark, you're a consultant. What's the answer?
I've got a whole team of experts.
Don't tell me it depends.
Right, you're the CEO of a consulting company, so that's your answer. It depends on a lot of things, but I'll say this, that this idea of creating the utopian data model that includes everything, that is just a reflection of your entire data warehouse, ain't gonna work. We get to a point where a data model will reach a point of critical mass, and we're working around ambiguous relationships, and we're just having to work around limitations. When you start to get to that point, that's a good sign that this might be a cutoff point for a data model. Back in the days of multidimensional, and when we were cutting our teeth on analysis services tabular, a lot of us went down that road, and we would create data models with 60, 80, 150 tables, and we have a lot of war stories to tell about those projects. They were complicated and difficult to manage. So, you have to, at one point, naturally, you're going to say, you know what, this is a model that is optimized for my sales team, and it has all the sales stuff in it, but HR gets another model. There might be common dimensions, which means that there may be some duplication between those models. Again, it depends, and those trade-off decisions, and at what point do you transition? At what point do you make another copy of a dimension in another model? All those things are negotiable. I think that Gen 2 composite models are going to solve a lot of those problems, but I think that we're all going to make a lot of mistakes before we figure out exactly what the best practices are. So that's my answer. Paul says we use direct query because we've invested heavily in row and column level security in our EDW. Is there a better way? We also have row level security in analysis services and Power BI. It works much the same way that it works in SQL Server. It's not live, it's on a copy of your data, and you need to realize that when you're in import mode, that you are dealing with a cached copy of the data. I will say that in my experience that choosing to use direct query for that reason and that reason alone probably limits your options significantly. So if you can implement row level security properly over a tabular model that is mostly, if not all, in import mode, you will likely have a much better experience, and your users will have a more performant, more flexible reporting experience. But yes, you're managing security in two places. You're making good points, Paul, and I agree with you. It's a trade-off, but there are trade-offs either way, and that's why Mark and his professionals get paid the big bucks to solve problems like this. Were there any other questions that I had missed? or any other questions since the chat.
Okay, well, thank you, Paul.
Hi.
Go ahead, sure.
You had a link to Composite Models for a specific article with Power BI. Could you post that link in the chat for us, please?
Yeah, that's a good idea. So let me go grab that. Let's copy.
Thank you.
Yeah. There is it's an earlier version of this presentation on my blog. If you go to the presentations page, and the link that I just sent you didn't exist at the time, but there was an earlier announcement just about Microsoft's intention to introduce this feature. So this is the most up-to-date information about that.
And then Carlos had a question in the chat. If you have separate models, can you pin visuals from those models on the same Power BI service dashboard?
Yes, you can. And that's really one of the nice things about dashboards. And keep in mind that the word dashboard means different things to different people and different products. So in the Power BI world, a dashboard is exactly what I described, and what Carlos is asking about is naturally in Power BI, a data model. You know, we can have data from multiple sources, but we can't surface visuals in Power BI report pages from multiple models until we have Gen 2 composite models, that is. But right now, today, if I have model A and model B, well, if I connect to model A, my reports can only visualize data from model A. But a dashboard can have pinned tiles from any of my reports within my Power BI workspace.
Well, thanks, Paul, so much for speaking to our group, and thanks everyone for making it tonight. And we hope to see you at a future meeting. Really appreciate your ongoing support of these groups and of the community. And have a great night, everyone.
Thank you. Good night, Mark. Thanks again.